Welcome to D-Lab everyone. In this video I'm going to give you guys the details on how to build your own dynamic 12AX and 12AT7 tube tester using a repurposed Heathkit model HD-15 foam patch. I built this unit about 9 months ago and produced a demo video on YouTube, but now for you guys I'm going to give you the inside scoop and a schematic so that you can build your own. Well, here's a quick overview so you can see the layout of the device. As I stated, it is built in a model HD-15 Heathkit foam patch. I utilized the original meter and the selector switch. This switch actually toggles between 12AX7 or 12T7 mode. This switch down here selects which section of the 12AX7 the meter is looking at. This receiver gain now turns into an input gain so you can inject a signal into the tube. Power supply is based on a Stancor P8173 power transformer. You can pick these up on eBay for like 20 bucks. And it has a 9-pin cinch connection for the 12AX7 or 12AT7 to plug into. Alright, now here's the insides. I do not have the tube socket wired yet. What I do is I'll wire that, allow it to float, and then I bring it in to the bottom of this top panel and insert the screws. That's the last step. But for me to show you guys the insides, it wouldn't be possible if I had that wired. So here's a good close-up. You can see I reuse this rear switch as the power. This pot is the null adjustment, so that's to balance your filament circuit. It has an IEC power input jack. You can carve that out with a Dremel. It's quite the job. Or you can just hardwire this thing. I used a modified D-Lab Cub 1 power supply board. This has two 68 microfarad caps at 400 volts. Fuse holder. We'll flip her around. There's your input jack. It goes through two 68K resistors to the 1 meg level pot, and that signal goes to the 12AX7 or 12T7. Here is that selector switch. This one changes the bias for the 12AX or 12AT7 tube. I'm going to pull this out and tilt it up so you can see how those 1K resistors are wired on the back. Here is our monitor meter. It is simply looking at the cathode voltages of each triode of the 12AX7 under test. And of course we have an idiot light here which backlights the meter, so when you turn it on it glows in the dark. But here's a close-up of the tube selector switch. So when it's in the counterclockwise position, that's 12AX7 mode, which puts one of the 1K resistors in line with the cathode of the tube. When you go over to the AT7, it shorts the two resistors to give you 500 ohms going to the cathode of each triode. Let me give you a little close-up view so you can see exactly how this device was constructed into the Heathkit foam patch. Don't know if I covered these two 1/4 inch jacks on the rear of the unit. These are the triode section of the tube you're testing. So there's two triodes, so you have A and B output. You'll see that on the schematic. This allows you to monitor the signal for microphonics with an oscilloscope, or you can actually pump the audio from this device into an amplifier and listen to the little tube that you're testing. Here we are, very close up on the inside. My input jack, and it's grounded. And then we have the two 68K resistors that are going to this dual section 1 meg pot, and they go to the center terminal. These two wires will go to your 12AX7 inputs, pins 2 and 7. You'll see all this on the schematic. Then of course we have our bias selector switch, which is either applying 1K or 500 ohms depending on which tube you're testing. There are two 0.02 microfarad coupling caps that go to the plates of the 12AX or 12AT7, and then that passes the signal to the output jacks. Over here you have the rear of the null pot, which is a nice landing spot for your filament voltage, and of course you can zero out any hum that you may have, and these two yellow wires will go to the filaments of the tube. So one goes to pin 9, one goes to pins 4 and 5. If we look close at the D-Lab Cub 1 power supply board, you can see that it's been modified. So we come through with our rectifier diodes, we go through a 22K resistor which goes to the second cap. Then I have the 200K resistors that feed the plates of your tube under test. So I had to actually cut the trace right here so I could separate those and modify it for this application. Well, here's the final wiring on the little tube tester. You see I have my 9-pin socket wired, kind of hanging in the breeze, waiting to screw into the top lid. My power transformer, my high voltage is coming down to the two diodes. Center tap goes to ground. The green is my filament line and the gray goes over here to the lamp. We're ready to reassemble. Alright, this is the tricky part. When you get ready to assemble the unit, you're going to have to reach in here and pull that tube socket up into its hole. Make sure that none of the wires underside get pinched or shorted during this process. Alright, we'll give this thing an initial test. We're going to start with a 12AX7 looking at triode A. So here is a nice mullered 12AX7. Plug it in, turn it on, see your meter lights up. In a second you should see the current flowing through that tube. And there it is. So that is A section triode. There's B. Alright, let's put in a 12AT7. Now once this is powered up, you can just pull the tubes out. No harm done. Just be careful when you plug in your new tube under test. Now we have an AT7 installed. Here's section A, section B. So in comparison to the original unit that I built, I noticed the sensitivity on this meter was better. So in other words, if I would put a tube in on my original unit, I would see the 0 point on the meter, and this one was around +2. So even though they're the same part number and the same rating of the meter, there's obviously variance. That could be in manufacturing or age. So I ended up adding a shunt across the back of this guy to get him more in line with what I would expect to see. I'll put that information on the schematic in case you run into the same problem. You can actually calibrate that meter. Alright, so at this point I'm going to cut to the original video that I shot of the first unit after I built it, so you can see step by step how to operate this little device. You'll find that this thing is extremely handy on the test bench, especially when you're tracing down microphonics and noise in amplifiers. Tube checkers can check a tube, but they won't show you if they're microphonic. This device will. If you guys want a schematic, just email me. I'll be glad to send you a copy. Hope you enjoyed the project. Well, let me walk you through the controls. Underneath the meter, you see this little toggle switch, and there's A and B. This is section A, which is one triode in the 12AX or 12AT7 tube, and this is section B. Okay? When you flip this back and forth, you'll actually see the idle current of each triode on the VU meter. That's what its purpose in life is. It's going to give you a wellness check. So let's say we're testing a 12AX7. The bogey is 0 on the meter, which indicates approximately 1 milliamp of current. If I go over to the 12AT7, there's different resistors that switch in to bias that tube, and you should get about the same level, 0. Okay? So this switch is either for your 12AX7 or your 12AT7, and you insert your tube into the test socket on top. Okay? Here is my gain level. Okay? So under a no signal condition, run this guy full bore, and that puts the 1 megohm of resistance to the grid to ground on each of the triode elements. This jack is an audio input jack. so you can inject either an audio generator or your guitar and watch the signal on your oscilloscope. On the rear, we have our 120 volt AC input, and there is a fuse internal. This knob is the null adjustment, okay, and that's what it originally was on this unit, so it's kind of cool because I elected to have that same feature on my dynamic tester. So this null adjustment actually balances the filament lines. So you know, on some amps you simply have 200 ohm resistors going to ground to give that balance of your filament circuit. This one here allows you to adjust it, and on the scope you would actually see a slight reduction in noise level because we do not want AC interfering with our test on the filaments. Okay. Then we have our A and B output. Those are the individual outputs of the triodes. You can either hook these to your oscilloscope, or you can pipe this through into an external amplifier and listen to the signal of that preamp tube. Alright, let me give you a live demonstration of this unit with a 12AX7 from the Deluxe. Alright, so I'm going to take my tube, plug it in, which is the 12AX7, and flip it on. You should see the current come up here on the meter, showing the tube warming up. There she goes. So you can see it's really close to the 0 mark. That's section A. There's section B. So right now the tube is idling. We're watching section A on the oscilloscope. So if I were to tap on the tube, I should be able to see if there's any microphonics on the scope. Now I do not see any, which is a good sign. Let's take another tube, an old crusty 12AX7 that I have out of my junk box, and let's see how it performs. This is a very vintage tube. I don't even know who makes it. There's some strange identification on it, but who cares? Here we go. Watch for the warm up. Oh, there she is. Once again, pretty good idle current and pretty balanced. That's the other advantage to this unit. If you're trying to find nice balanced tubes, especially for your inverter circuit, this will give you that indication on the meter. It's really nice. Okay. All right, same deal on the scope. Let's see what we got. Now you can see there. You see we got some little events on the scope. So this guy's microphonic. So if you were to put that in your amp, it'd probably be a noise monster. Alright, let's check a 12AT7 now. So you can simply unplug these. You do not have to cycle the power. So here is a 12AT7. This was the reverb driver tube from the Super. So we're going to go to 12AT7 mode. Just warming up. You can see our idle current isn't exactly up to par, a little weak. What's the other side look like? He's a little bit better. Let's see if we have any microphonics. Oh yeah. This one's pretty sensitive. You see that? Look at that. So let's take a new 12AT7. I happen to have some Mullards, and let's re-perform this test. Alright, so I guess I should have looked before I told you guys I had a new Mullard, but I do have a new Channel Master 12AT7. We'll put that one in and see how it looks compared to the 12AT7 from the Super. So you can see our idle current is a little bit higher. How about microphonics? Look at there. She's clean as a whistle. Alright. So that shows you how this little unit can detect microphonics, and you can test these things individually without having to put them in your amps and say, well, I think I hear a noise, maybe I don't. This is a foolproof method for you to put in a good tube to begin with. Alright, now I'm going to take my audio generator and we're going to go back to the 12AX7 mode. We are going to inject a signal and look at it on the scope. Alright, so this is the original 12AX7 that I removed from the fender. We're in 12AX7 mode. Let her warm up. Alright, now I have my audio generator set. We're going to pipe the signal in and look at the output on the scope. So there she is. Nice clean sine wave. So you can do the same thing with your guitar if you do not have an audio generator, but of course your guitar is not going to give you a nice clean sine wave to look at because you got other things going on right when you're playing the strings. But what's nice about this, you can say, okay, I've got a nice clean tone. How does it sound in my amp? And since we're only using 1/2 of the 12AX7 at a time, you won't overdrive your amp. You can actually use this in series and listen to that tube before you ever install it. Alright, so let me hook up a guitar so you can see that on the scope. Alright, I've connected a guitar to the input rather than the audio generator. One thing I didn't mention to you guys is this input actually goes through a dual stage pot which feeds the grids of both triode elements. So the signal that you're seeing going in section A that we're monitoring would also be going out of section B. So you can flip your cable back and forth and see the signal on both halves of your 12AX7. Alright, so I'm going to go ahead and turn her up a little bit. So there is your guitar output. Okay, so you can see I'm at about 0.1 volts per division. So you're seeing maybe a 1/2 volt signal or so. So if you were to throttle this back, you could actually drive your guitar amp and listen to that tube.